Hello everyone, let's look at the problem subarray sum equals k. The brute force approach to solve this problem would be to go through all the subarrays I, j such that I less than equal to j, which will give us all the subarrays like 0 to 0, 0 to 1, 0 to 2 and so on. And when we start from 1, we'll get 1 to 1, 1 to 2, 1 to 3 and so on. In this case, we'll have an order of n square subarrays. We'll have to go through all of them, calculate the sum and increment the count if the sum is greater than k. Time complexity of this approach would be O of n square and space complexity will be O of 1. To optimize this, let's consider this example where k is equal to 4 and try to calculate the sum for each subarray starting at 0. Now in this particular example, we find 3 scenarios where we have sum equal to 4. But you will quickly notice that these two subarrays also have the sum equal to 4. If we try to generalize these cases, we can say that we are looking for all the subarrays from I to j whose sum is equal to k. Now if we look at any general subarray starting at I and ending at j, we can say that sum of I to j equal to sum of 0 to j minus sum of 0 to I. Now since the sum of I to j is the sum of any subarray, so we can replace it with k as we need to count subarrays adding up to k. And since we are going through the subarray, we can easily know the sum from 0 to j. So let's group the known values together. Now let's take a good look at this equation. This tells us that for the sum of I to j to be equal to k, for each j, there should be one or more values of I for which sum till I minus 1 is equal to sum till j minus k. I minus 1 because we need to include the ith element when we are calculating the sum from I to j. Or in other words, if we calculate the sum to j and at any previous point I minus 1, the sum was sum till j minus k, then we can say that sum of I to j equal to k. This means that we need to keep track of all the occurrences of the cumulative sums as we go through the array because I is a previous value, and because at any point j, the existence of the sum till j minus k at any previous point I minus 1 suggests that we have a subarray ending at j that has sum k. So we need to find out how many times sum of 0 to j minus k exists for an array ending at j to find out the frequency of the sum k. For this, we are going to store the values of the cumulative sum and their frequency in a hash map, and as we go through the array, we'll calculate the sum till that point in the array. Let's initialize the current sum. Then we check if the current sum minus k exists in our hash table. If yes, we increment the result by the frequency of that sum already present. Then for the current sum, we increment the count in the hash table. Now let's initialize the result and return the result. We also initialize the hash of 0 to be 1 because we want to include the case when the subarray starts at 0. Why? Because when we are accumulating the sum of subarrays, if the subarray sum equal to k, we would want to include that subarray in the final count. Since we are including count via sum of j minus k, sum till j minus k, we need to tell our code that we have already seen a subarray that has sum 0, hence hash of 0 equal to 1. And when we run our code, we see that it submits successfully. Thanks for watching.